Okay, so looking at the equational line, so this relates to the graph 1 and looking at letter C. So here it says write a mathematical equation that describes the skater's motion. Let me pull this up so I can make sure to. Okay. And so we're looking at the mathematical equation. Again, this is going to be that equation for a line. And so I'm going to try and make this work. And there you go. So if remember kind of key thing, and this is way back at the beginning of the year, so it has been quite a while. So really kind of key thing here is when we're looking at the equation of a line, the equation remember is going to be y equals mx plus b. So what I'm going to do here kind of quickly is go through and kind of reinforce what each of these are and then kind of color code it with the graph. Okay. So the kind of the first thing here is looking at the y. So remember the y is always going to be equal to, there you go. Okay. So remember the y is always going to be equal to the variable on the y-axis. And one of the things that I noticed yesterday is, and this probably relates to your math class, where everybody just wants to leave the y as whatever, as just y. But for science, what we should be looking at is we should look at what the variable actually is in that y-axis. In this case, our variable is going to be position in meters. So that's kind of the key thing there is the y. We always want to write it out completely as we see on the graph. Okay. So you write the text, we'll go green for the next one. So the next part then, remember the m is going to be equal to the slope of the line. So, and I'll go through and kind of show you how to calculate that out again, all right, because it has been a little while since we've done that. Okay. Okay. So then looking at the x, just kind of like the y, this is going to be related to the variable on the x-axis. Okay. So in this case, when we look at the variable on the x-axis, we can see here, this is going to be time in seconds. Okay. Okay. Then the last piece is looking at the b. Right? So kind of remember back to the beginning of the year, b is going to be equal to the y-intercept. Remember that's where, and again, looking at this is so this is kind of relates to where the line crosses the y-axis. And so kind of looking on this graph here, we can see is where it crosses the y-axis is kind of at this point right over here. So we'll kind of get into that here in a little bit when we actually write this out. Right. So that's kind of key things, or what each of these mean. If you don't have this written down, what I encourage you to do is kind of write down everything I have kind of within this box. Right. So write down everything that we have inside this box, because this is going to be important information throughout the rest of the semester. Right. And this is something that if you're starting this right now, right, as we continue moving on, it's going to get probably more and more difficult. Right. If you get a good understanding of this, the rest of the semester will actually be that much easier. So that's why it's one of those key things that we do need to understand and need to be able to fill in correctly. Okay. So the first thing I'll look at quickly here is looking at the slope of the line. And so remember when we're looking at the slope, okay, start here. So remember the slope is looking at kind of the change in y. So remember we call that y2 minus y1. And that's going to be over x2 minus x1. So when we're kind of looking at this, so what we need initially is we need to identify at least 2 points on the line. And so for me, whenever I do this, I'm always looking at my line and trying to find, okay, where does the line cross, all right, where it crosses kind of basically like an X on the graph, or where it's crossing a point where the graph lines actually meet. So one line that we could use, we could look right up here on the top, so you can see, and remember this is always written as like XY. So here our X is going to be 10. And so then if we want to actually, fill this in a little bit as accurately as possible, we could say, okay, this is 10 seconds, this is the unit, and then on the y, it's going to be 30 meters. So this would be like the grid coordinates for this point right up here at the top. So it's 10 seconds and 30 meters. So you can look here on our x-axis, it's 10 seconds and 30 coming across the 30, and the 30 relates to meters. Okay. And there's two other places that we can use for this. We could look in the middle here where we have kind of like our 5 seconds at the 20 meter, or even easier if we look way down here in the corner, right, our data points are our x is crossing on the 0 second mark. So it's right at the econ base. We can say it's 0 seconds. All right, then looking on the y-axis, what we have is we have 10 meters. And the other place, if you look, that you can get this information is actually from the data. So I'm going to try and do this and not screw up too much. So you can see here, we have our 10 seconds and 30 meters and our 0 seconds and 10 meters. So if we're looking at this, like the t, these would be our points on the x-axis, and the x in meters would be our points on the y-axis. Perfectly lined up. Okay. So then once we have that information, let me get my text going. So equals. So when we look at this, we can see, our y2, and with this, you can use either of these as kind of your y2 and x2. Right? I always kind of start top right for my 2's. I got somebody join in. Ian is. Oh, Ian can wait till next hour. Okay. So when I'm looking at my y2 is going to be 30 meters. So I can put this up here. So I have 30 meters minus my y1, which in this case is going to be 10 meters. Nope, I missed the m here. Sorry about that. Let me like this quick. There we go. 0 seconds and 10 meters. There we go. Okay. So equals. So yeah, our 30 meters minus 10 meters. Right, so we're going to put that over our x2. So our x2 in this case is going to be 10 seconds. Because since I used the 30 as my y2, that means my x2 has to be the 10. So we're going to subtract that from our x1. In this case, it's going to be 0 seconds. Okay. So let me get my line in here with this. So then what we can do is we simply calculate this out. So we can take 30 meters minus 10 meters, and I missed the m again. Okay. So we take 30 meters minus 10 meters. So what we get is we're going to get, it's going to be 20 meters. Right, over, and we have 10 seconds minus 0 seconds. So 10 minus 0 is 10 seconds. Okay. So what that gives us, then we can actually calculate this out. So you take 20 divided by 10. Yep, we'll get there, Karen. So we take 20 divided by 10. So their answer then here is going to be 2 meters per second. So our slope in this case is 2 meters per second. Okay. Okay. So when we're kind of looking at everything now, we can actually build the equation of the line. So if let me get this and we'll go back in. So my line, remember, it's always going to start off, my first part here is the y. So we're looking at the variable on the y-axis. Remember, the key thing is we write out the entire variable. So here I'd say position in meters is equal to. All right, so then we have our m, which is the slope. We can see our slope is right up here, so it's 2 meters per second. Times, so remember it's mx, so it's m times x. Then our x is the variable on the x-axis, so this is time in seconds. And then we find our b, which is the y-intercept, and it crosses the y-axis. We can see here it crosses at 10 meters. So when we're looking at the mathematical equation or the mathematical equation of the line or the mathematical equation for the skater here, you can see the equation is the position in meters is equal to 2 meters per second times time in seconds plus 10 meters. So what we can do now is we can actually make predictions using this equation to determine either where the person is after a certain amount of time or how long it took them to get to a certain point. Now, for example, say we know that the skater is now at 100 meters. So what we can do is we can actually fill this in. We can say, okay, we know the position is 100 meters, right, which is going to be, and let me move this a little bit. Right, so that's equal to, and we leave everything else the same. So it's meters per second, okay, times the time in seconds plus 10 meters. So once we have this information, we can now solve and see how long did it take this person to skate to the 100 meter mark. So the first thing we do is we're going to subtract, our 10 meters across, and to cancel these out. Because what we want to do is just kind of like in algebra, we want to get the time in seconds by itself. Okay. So we can put our lines here. So the next part of our equation we're going to see is it's going to be 90 meters is equal to 2 meters per second times time in seconds. Okay. And now since we're going to be doing it like just like we saw up here, since we're adding 10 and subtracted, we're doing the opposite mathematical property property. And so here, since we're multiplying 2 meters per second times time, what we're going to do is we're going to do the opposite of that. So we're going to divide both sides by 2 meters per second. So if we take 2 meters per second, make sure I get this, 2 meters per second. So what we can do then is we can see now we're going to cancel. So 2 meters per second divided by 2 meters per second is canceled. And I'm going to use a different color from here. And if we take meters divided by meters, the meters will cancel. So and since since the seconds is in the kind of the bottom of the meters per second, it'd become the top. So we'd say here, we'd have 90 divided by 2. So in this case, in order for this person to get to the 100 meter mark, it's going to take them, 90 divided by 2. So it's going to take them 45 seconds to get to the 100 meter mark. Okay. So that's why we want to make sure we have the equation. We got this down because we can use the equation, right, to solve either their position or their time if we know one of those. Okay. So like I said, I'd strongly encourage you to make sure you have everything kind of written out that's in this box. All right, so that way when you go through and you fill in the equations of line, right, you always know exactly what you need to put in there. Right, because it's going to be very, very helpful as we move through the rest of the semester. Right, so let me clear the rest off really quick. And I'm just going to leave this up here for a moment. I'm going to erase a couple other things quick. Okay. Okay. So like I said, I would strongly encourage you, if you have not written this down yet, to write it down. Okay. The other thing that I wanted to go through, and I did have a couple of students in the class ask questions about this. So looking at section 3, and so when we're looking at, our skater is looking at a different trial here. So we're applying the position, and I'm going to do this kind of really quickly. So I get my lines. And this works. So we went from 0. So there we go. And then for 2 seconds they stayed. And they went to back to 0. Okay. Yeah. So what we should see for 3 is a graph that looks somewhat similar to this. So basically what this shows is that the person started off at the 0 meter mark at 0 seconds. They started skating away from their starting point. All right, so they skated 12 meters away, basically paused for a second or 2 seconds, all right, then skated back to where they started. So they basically skated 12 meters, turned around, and skated back 12 meters. Okay. So when we're looking at, back to my mouse, come on, there we go. So we're looking at like D and E. So there's a couple of key things here. So the velocity and speed. So yesterday I did make a mistake and I was kind of using velocity and speed kind of interchangeably. They are technically 2 slightly different things. So if we look at like the physics classroom that we're going to be using again kind of throughout the year. So speed always refers to basically how fast an object is moving. So a lot of times you think like, how fast a car is moving, right? Or basically, how quickly you're running. Whereas velocity, we call this a vector. So basically you're looking at the rate at which an object changes its position. So you're going to compare where you start versus where you finish. And one of the tricky things with this one, and I'm going to clear this for a second. If you don't have the information for the equation line, let me know and I'll make sure to get that for you. It'll be easier if I can clear this for the last part. Yeah. And so when we're looking at velocity, we're comparing, okay, it's the displacement. So it's where you start versus where you finish. So you can see here their final position minus the initial position. And if we look, we can see in this case, the runner's final position, if we look at their meters, is 0, and their initial position is 0. So basically they ran, turned around, came back. Right? Whereas we're looking at the average speed, we're looking at how far did they run, right, versus how long did it take. So when we're looking at this, let me pull my lines up really quick again. So when we're looking at like velocity, we're comparing, so where did they finish versus where did they start? So if you notice, in this case, they finished at the 0 meter mark. They also started at the 0 meter mark. So their velocity basically is not going to change because they're back where they started. Whereas when we're looking at speed, we're going to be looking at, okay, how far have they run total. And so if we're looking at this, you can see they started at the 0 meter mark, they ran 12 meters, paused, and then ran 12 meters again. So you're looking at, okay, their total distance traveled is going to be 24 meters. And so hopefully kind of that clarifies that piece a little bit. If you need help with that or additional help, please let me know. Because I understand that these two questions can be a little bit tricky. All right, I'll go through and kind of explain those a little bit better tomorrow, before we get into the new assignment. Okay. And